All right. We're going to try question number 6. We're going to rotate the sine curve over the interval of 0 to pi. Since this is where pi would be. And we've got 0. Okay, those are the x values. And we're going to create, I should say, the radius here being the y coordinate value, this y value. We're going to find the surface area of, it's not a solid since we didn't rotate the region, we rotated the curve. Surface area of that kind of, it's really the lateral surface area of a hollowed out solid of revolution. So this is 2 pi r ds. And we're going to have to integrate now over the interval 0 to pi, 2 pi, where r is the y coordinate value, which is really going to be sine of x. So we have sine of x ds, and the ds portion, we'll bring this all the way down here. I'll rewrite it. 0 pi 2 pi sine square root 1 plus y prime squared dx. Since y is sine, taking the derivative of the sine curve, the derivative of sine is cosine. So 1 plus y prime squared becomes 1 plus cosine squared. And again, we're going to take the square root. Now, be careful here. In the past, some students think that this is a trig identity and that can be replaced with sine squared. It is not a trig identity. Okay, 1 plus cosine squared is not sine squared. 1 minus cosine squared is sine squared. So this arc length, surface area, okay, we got to remember here, we're working on surface area. Is going to be working with this integral. All right. So pulling out the constant 2 pi, you have sine square root 1 plus cosine squared dx. All right. Now, so we're going to have an integral right here to work on. And I'm going to take this with every sort of detail. We're going to use a u sub here. We're going to try u sub, where u here is simply going to be cosine. So you're going to see that this is eventually going to turn into a trig sub situation. One that maybe you recognize and have seen before, but let's start by looking at this in terms of u sub first. And so du, derivative of cosine, is minus sine dx, so that dx becomes du over minus sine. And let's bring down the 2 pi. Okay, we're going to try to bring that down. And we're going to pull out the constant here. Okay, so it looks like we have 1 plus u squared here du. Okay. Now, this is what I'm going to say when we integrate. Now, this function here, you're going to have to use trig sub, because this is going to be a square root a squared plus u squared situation. It's a trig substitution integral. And if you recall, u is a tangent theta. The radical a squared plus u squared is a secant theta, and du is a secant squared theta d theta, just by trig substitution. Trig sub. Well, a squared here is 1, which means a is 1. So now you have u going to be tangent theta squared root of 1 plus u squared is secant theta. Derivative of tangent is secant squared theta d theta. So this is going to be our trigonometric substitution now. All right. So let's see what this integral becomes. Let's bring down the constants all along now. Okay, like the negative 2 pi here. And that integral is going to be, I'm going to bring down the constant. I'll leave it blue. Let's see what we have here. The radical is secant theta. D theta is secant squared theta d theta by trig sub. So we get negative 2 pi, the integral of secant cubed theta d theta. All right. Now, this is my remark to you, like it has been. Some of these integrals you really want to always memorize. They show up a lot. The integral of secant cubed is 1/2 secant theta tangent theta. All right, let's remember that integral. Plus, depends on this, plus the natural log absolute value secant theta plus tangent theta. Let's move this over. And that's going to be 1/2 secant theta tangent theta. I'm going to distribute the 1/2. It's going to not fit, so we'll put 1/2 natural log absolute value secant theta plus tangent theta. Okay. Let's actually bring this constant in. Negative 2 pi. So you're going to end up with negative pi secant theta tangent theta minus pi natural log absolute value of secant theta plus tangent theta. Okay, let's remember here that u is tangent theta, so we're going to have to use that information to, go back in terms of our u now. So we have tangent theta is u over 1. We're going to need more paper, I guess, or add a page. All right, let's bring our right triangle here. Theta, definition of tangent. Okay, now we need secant theta. We already know tangent theta is u. So let's see, what color? I guess this is blue. So we're going back to blue. Tangent theta is u. U. We need secant theta now. So cosine theta, though, is adjacent over hypotenuse. And so secant theta is the square root 1 plus u squared. So all right, so here's what we're going to end up with. Negative pi times u square root 1 plus u squared, okay, minus pi square root, we need natural log, put it down here, minus pi, natural log, the absolute value of square root, yeah, 1 plus u squared plus u. Now, this is the integral in terms of the variable u now. And let's double check. If we change these, we might have to go back now to, we didn't change the limits. Let's go back here. This is what we have to evaluate now, okay? Looks like these limits here, this is in terms of x. This is x. Let's go back to the variable x. And in order to do that, we got to use the substitution of u being cosine. So since u is really cosine, here's what we end up with. Let's make sure what color it is just in case. I guess it's still blue. So u is cosine. So I have negative pi cosine x. Square root 1 plus cosine squared minus pi natural log absolute value square root 1 plus cosine squared plus cosine. Okay. So now we can evaluate this at the limits. I guess it was 0 to pi. So we'll have f of pi minus f of 0. So here you go. Okay. All right, so let's try to get these values. Square root 1 plus cosine squared pi okay, so this is the first part minus, I'll put a parentheses, f of 0. So it'll be negative pi cosine of 0 square root 1 plus cosine squared 0 minus pi natural log absolute value square root 1 plus cosine squared 0 plus cosine 0 in absolute value. Cosine of 0, ladies and gentlemen, let's remember this is negative 1. So cosine 0 is negative 1, cosine pi. Okay, we're going to square that in some of these cases here. Cosine 0 is actually 1. So this is 1 1. 1. So let's be careful. Negative times a negative. This will be pi. Square root 1 plus negative 1 squared minus pi natural log absolute value square root 1 plus negative 1 squared minus 1 in absolute value minus in parentheses. I'm going to put this negative pi times 1 square root 1 plus 1 squared minus pi natural log absolute value square root 1 plus 1 squared plus 1. And let's still figure out some arithmetic. This is 1. This is 1. This is 1. And this is 1. So it looks like we have pi times the square root of 2 minus pi times natural log absolute value square root of 2 minus 1 minus, okay, negative pi square root of 2 minus pi natural log absolute value square root of 2 now plus 1. Let's now distribute the negative sign. Square root of 2 pi. We're going to change the order there. Minus pi natural log. The square root of 2 minus 1, by the way, is positive, so I'm going to remove the absolute value sign. Now, minus and minus makes that plus. Plus square root of 2 pi plus pi natural log square root of 2 plus 1 for the same reason. And I think we can combine only these two terms here. So you will end up with 2 square root of 2 pi minus pi natural log square root of 2 minus 1 plus pi natural log square root of 2 plus 1. Here's your surface area. We can do some simplification. Okay, like over here for the log, maybe. If you're interested in that kind of thing. I mean, this is kind of fine as an answer. But you may consider simplification. If you look in back of the book, right in here, if we write this as pi natural log square root of 2 plus 1 minus pi natural log square root of 2 minus 1, they can factor the pi out. And you're going to see probably an answer that looks like this here for this portion. So the surface area will be 2 square root of 2 pi plus pi natural log square root of 2 plus 1 over square root of 2 minus 1. And we'll just leave it as, you guys know this is surface area. And I guess we'll write it as a block there. So this is how we integrate. And this is how the answer for number 6 is. Surface area. Okay. Okay, number 7. We're going to rotate this curve about the x-axis here from 1 to e. And what you'll see here is your radius again is that y coordinate. So r is the y coordinate value, which is the value of this function. And let me move this all if I can. Let's write it over here so you guys can see. 1/4 x squared minus the natural log of x. So your surface area is going to be the integral 2 pi r ds. So then the surface area will be the integral from 1 to e 2 pi r is that function 1/4 x squared minus natural log. Okay, and then your ds now is going to become square root 1 plus y prime squared dx. Okay, y is 1/4 x squared minus natural log, so that the derivative is what we have to take. Which will be 2/4 x minus 1 over x. Let's double check. There's a 1/2 here. All right. Let's not forget that. That's an important detail. 1/2 natural log x. Okay. Okay. Okay, so y prime becomes 1/2 x minus 1 over 2x. So 1 plus y prime squared becomes 1 plus 1/2 x minus 1 over 2x squared. So let's just focus on some algebra here. And like previous problems associated with surface area and even arc length, I want to remind you that at this step here, you're going to see again that perfect square trinomial situation here. Okay? When you use FOIL, it's going to become that case I wanted you guys to study and remember, because it does show up often. Meaning, by FOIL, you're going to get x squared over 4, first term, outer terms, minus 1/4, inner term, minus 1/4, last term, plus, looks like 1 over 4x squared. So you get x squared over 4 minus 1/2 plus 1 over 4x squared. That's in purple. Now don't forget you have 1 plus over here. And we're going to combine these constants here. 1 gets replaced with 2 over 2. So you end up with x squared over 4 plus 1/2 plus 1/4 x squared. And I guess we're using purple, so let's continue. right? Oh, well, no, I guess we were fine. We can still manage that, I guess. All right. But here's my point. This, again, is all under a radical. However, what you see here is a perfect square trinomial. What does that mean again? This was the point what I made earlier and in the past, in purple here. You got the x squared over 4 minus 1/2 plus 1 over 4x squared is really what you see up here. It's 1/2 x minus 1 over 2x to the second power. So that difference here now in this situation is a plus, meaning this is x over 2 plus 1 over 2x to the second power under the radical. And we're going to use, again, the absolute value of anything squared. Well, let's remind you, the absolute value of a is a square root of a squared. And this thing is positive when a is positive. So over the interval from 1 to e, and this is the detail, right? Because x is between 1 and e. This portion is positive, okay? This is what we're saying. X over 2 plus 1 over 2x is strictly positive. So we can say that that's going to be the absolute value of x over 2 plus 1 over 2x, which is, because it's positive, just x over 2 plus 1 over 2x. So we're using, a couple of things from pre-algebra there. Definition of absolute value. And because it's positive, we can remove the absolute value sign. Now, that x over 2 right in here plus 1 over 2x, this goes right in here. Let's see if we can see everything here. Okay. 1/2 x plus 1 over 2x. So my surface area, now, to put all this together, we'll pull out the 2 pi, 1 over e. Remember that function to begin with, okay, was 1/4 x squared minus natural log minus 1/2 natural log x. That factor is right here. And we pulled out the constant. 1/4 x squared minus natural log 1/2 natural log x. Okay. 1/4 x squared minus 1/2 natural log x times x over 2 plus 1 over 2x dx. This is what you're going to need to integrate. You're going to have to integrate this here. Now, before you think of a process of integration, you might say, well, what do we do? Do we do u sub? Is that a trig integral, partial fraction decomposition? Nope, I'm getting out the purple again. And you guys know whenever I do that, what that means is we got to use what? Algebra. FOIL. Okay, we're going to have to FOIL this. So let's do some FOIL. First term, 1/2 x squared times x over 2. Now the outer term, 1/4 x squared times 1 over 2x. The inner term, minus 1/2 natural log x times x over 2. The last term, minus 1/2 natural log x times 1 over 2x. So doing some algebra here, we get 1/8 x cubed plus, looks like this is 1/8 x minus x over 4 natural log x minus, let's write this as 1/4, I guess. Yeah. We'll say 1/4 x natural log x minus 1/4 natural log x over x. So, okay, there's a factor of 2 pi here, so we're going to have to take 2 pi, you integrate from 1 to e, 1/8 x cubed, 1/8 x, 1/4 x, natural log x, minus 1/4 natural log x over x dx. Okay. Now, let's see here. We're going to have, to focus a bit, I think it might be good to, we're going to break this up into 4 integrals here. So, all right. 1 to e, 1/8 x cubed dx. And I mean, we're going to take a chance. Here's what I'm going to do. I'm going to try to keep that constant in memory. And we're going to try to focus on these integrals here. There's going to be 4 of them. Okay, so bear with me on that. So, all right, 1 to e, 1/8 x cubed dx. And then we have 1/8 x dx. I mean, let's just write all the properties. Let's use properties of integrals here. This would be 1/8 from 1 to e x cubed dx plus 1/8 from 1 to e x dx minus 1/4 from 1 to e x ln x dx. And then minus 1/4 integral 1 to e ln x over x dx. Okay. This is by properties of integrals. And, you know, I guess we're just going to multiply that constant, that 2 pi for each. Okay. Let's just do it now so we don't forget. So we're going to get now, for the first one, a factor pi over 4. We integrate from 1 to e x cubed dx plus pi over 4, 1 to e x dx minus pi over 2, 1 to e x ln x dx, and then minus the pi over 2, 1 to e ln x over x dx. Okay, so just notice that I did do the constants after all. But what I want to kind of remark now with this question is simply that you're going to need to do 4 integrals now. Okay, so we might want to get some colors out, I guess, maybe for some of these. This one's going to be 1/4 x to the 4th. 1/2 x squared. So those first two are pretty simple. And here, I'm going to remind you guys, there's a nice formula. X ln x minus x that you may want to recall for this particular integral. Okay? And that's found by IBP. So if you said, oh, how do we do that one? That was integration by parts. Go back to your notes because some of those integrals, they show up over and over. This last one, though, I believe we even did this one. This is the only work I think we really have to do here. We're going to have to do some u sub now. Now, u in this integral from the past is natural log. So du is 1 over x dx, which means our dx will be x du. So we're going to have to use u sub. So that integral now is u over x, and then x du. Cancel these x's. Integrate u du, and then this one is 1/2 u squared. Don't forget, my u is natural log x. Okay, so that's 1/2 natural log squared x. All right, so take a look at all of this as I add a page, because you guys see we have some more work we're going to have to do here, right? So all of these we're going to have to evaluate from 1 to e. So I would say, let's just deal with the constants, I guess, okay? For each one. Here we go. Okay. And don't forget this one here. So this first one's going to be pi over 16 x to the 4th. Okay, so pi over 16 x to the 4th. Let's write that down here. Pi over 16 x to the 4th. And then pi over 8 x squared. Okay, and minus now pi over 2 x ln x minus x. So minus pi over 2 x ln x minus x. And then finally minus pi over 2 times the 1/2. That's minus pi over 4. Natural log squared x. And we're going to evaluate this all here from 1 to what? 1 to e. So we're going to have to find f of e minus f of 1. And I think what I want to do first, though, before we go there, is maybe distribute here. Okay. Let's make it a little bit cleaner. This is going to be this portion right in here. Minus pi over 2x, natural log x, plus pi over 2x. Alrighty. I'm going to write that down here. Yeah. Minus pi over 2x, natural log x, plus pi over 2x here. Alrighty. Now, this whole thing, maybe we can bring some of these terms down. All right. And this whole thing, we're going to evaluate from 1 to e. So we need f of e minus f of 1. Okay, so let's get to this. This will be pi over 16 e to the 4th power plus pi over 8 e squared minus pi over 2e ln e plus pi over 2e minus pi over 4 natural log e squared. And this is we're gonna subtract now. This is the first part. This is the f of e. Now minus, evaluate this with x is 1 now. Pi over 16, 1 to the 4th power, plus pi over 8, 1 squared, minus pi over 2 times 1, natural log 1, pi over 2 times 1, minus pi over 4 natural log squared of 1. All right, let's double check here because we're going back and forth. Pi over 6, 1 to the 4th, plus pi over 8, 1 squared, minus pi over 2, 1, natural log 1, plus pi over 2 times 1, minus pi over 4, natural log 1 squared. Let's do a little bit of work here. Natural log e is 1. So this would be 1 squared, which is 1. Natural log 1 is 0. This would be 0 squared, which is 0. So I'm going to kind of scroll out here, see if we can write things out a little clearer there. Pi over 16, e to the 4th, pi over e squared, minus pi over 2 times e. We might need another page. Okay. Looks like there's a plus. I'm going to write it down here, though. Plus pi over 2e minus pi over 2 times e plus pi over 2 times e minus pi over 4. Now minus pi over 16 plus pi over 8. This is going to be plus pi over 2. And it looks like that's about it. Okay. Now, I can distribute here the negative sign so that each one of these is going to be negative here. Okay? So we just distributed that negative. The terms that we can actually do arithmetic for now. The only terms, well, first of all, let's just notice here. this goes away. And then the only terms it looks like we can combine are these terms over here. And what I'm going to do is notice the LCM is 16. So I'm going to multiply this by 4, 2, 2, 8, 8. So that we have pi over 16 e to the 4th plus pi over 8 e squared minus 4 pi over 4 pi over 16 minus pi over 16 minus 2 pi over 16 minus 8 pi over 16. So we get pi over 16 e to the 4th plus pi over 8 e squared. Let's combine these terms now. So it looks like it's going to be negative 4 pi, negative 5, 7. Oh, they're all negative. 4 plus 1 is 5, 6, 7. That minus 15 pi over 16. So double check. You know, we've been writing these answers in black. Yeah, it looks like all those were minus. Anyway. All right. Okay, let's try this out.
Daddy, do you know what?
Okay. We're going to work on question 8. And we're rotating this curve about the x-axis to compute the surface area. So our surface area formula for number 8, 2 pi r ds. All right. Where r here, again, is that corresponding y coordinate, which is 4 minus x to the 2/3 raised to the 3/2. So the surface area formula is going to be the integral from 0 to 8, 2 pi r, which is really 4 minus x to the 2/3 raised to the 3/2 times 1 plus y prime squared dx. Okay. Now, y prime is going to be d dx 4 minus x to the 2/3 raised to the 3/2, which will be 3/2, 4 minus x to the 2/3, 3/2 minus 1 will give you 1/2, times the derivative of 4 minus x to the 2/3, and this is by chain rule. So we have chain rule here for a derivative. And this derivative will be negative 2/3 x to the negative 1/3. So that y prime will become 3/2, 4 minus x to the 2/3 to the 1/2, multiplied by negative 2/3 x to the negative 1/3. Okay. we're going to square this here. And this will become now, let's move some terms here first before we square. And this portion here looks like it's going to be -1 here. So that y prime squared will become -4 minus x to the 2/3 to the 1/2. X to the -1/3. We'll square that, and we end up getting 4 minus x to the 2/3 now, times x to the -2/3. And this is 1 plus y prime squared. Okay. And we haven't added 1 yet, but we're going to add 1 now. So when we add 1 to this is 1 plus, let me write this negative power. Okay. And I guess we can say we're going to distribute this x to the 2/3. And we'll get some simplification here, where this is going to be a -1, really. So that we have 1 plus y prime squared becomes 4 over x to the 2/3. Let's take the square root. Now, this will be the square root of 4 over the square root of x to the 2/3 now, which is 2 over x to the 1/3. So we're going to use the square root of a quotient is quotient of square roots. Okay. Now, the arc length formula, though, was the integral from 0 to 8, 2 pi, y, or the function is right here. Okay, so we're going to have to write that down. 4 minus x to the 2/3. The whole thing raised to the 3/2 power. Now this will be times 2 over x to the 1/3 dx. Okay, let's kind of deal with some of these constants here and then see what we can do now with this. So that the surface area will become 4 pi, 0 to 8, 4 minus x to the 2/3 raised to the 3/2 power over x to the 1/3. Okay. So this is the portion that we're going to need to integrate. Okay. So the question now is going to be, how do we integrate this particular function? Okay. Let's get this iPad working here, this iPencil. We're going to use U substitution here. This is how we're going to integrate. Where U is going to be 4 minus x to the 2/3 power, which means du will be the derivative of this. It'll be negative 2/3 x to the negative 1/3 power dx. So that dx will be du over negative 2/3 x to the negative 1/3 power, or dx will be negative 3/2 x to the positive 1/3 du. So let's double check that that's the case. So in red, this integral is going to be now u to the 3/2 power over x to the 1/3, and dx will be negative 3/2 x to the 1/3 du. So we have cancellation here. Negative 3/2 integral u to the 3/2 du. Now, we're going to change the limits. We're going to do a couple of things here. Remember, this is the limit as x is 0 and x is 8. I'm going to bring down our 4 pi. That's one thing. Okay, so let's remember that constant. Now, we're going to have to write the limits for u here. So, using u being 4 minus x to the 2/3, when x is 0, u is going to be 4. Okay, so if you want to kind of look at that information here, this is 4 minus 0 to the 2/3, which is just 4. So the lower limit value will be 4 now. So I'm going to put that 4 down here. Okay. So when x is 8 now, we're going to plug in an 8 now for x. So when x is 8, u will be now 4 minus 8 to the 2/3. So u will be 8 to the 2/3, remember, is going to be 8 to the 1/3 squared. And 8 to the 1/3 is 2. So this is 2 squared. So my u is going to be 4 minus 4, or u now becomes 0. So our upper limit is going to be 0 here. Okay, so this is going to be 4. And this is 0. So this is what we get here for the various limits. This is the lower limit, and now this is the upper limit. So you look at this and you say, hey, these limits can be reversed if I factor out a negative sign. So we have 4 pi times a positive 3/2, and that can change this from 0 to 4 now, u to the 3/2 du. And if you prefer red, since we're still doing that u sub, I guess, and let's also simplify here. Let's do one step at a time. 4 pi times a positive 3/2, 0 to 4. We can switch the units now, the limits. So this becomes 2. We end up now with 6 pi. We integrate from 0 to 4. U to the what? 3/2 du. And now let's integrate. U to the 5/2 over 5/2. U is 0, u is 4, 6 pi. So we get 6 pi times 2/5. U to the 5 halves, u is 0, u is 4. So we get 12 pi over 5 now. This will be u squared square root of u. U is 0, u is 5. If we remember how to simplify u to the 5 halves, right? I taught this to Calculus 1 students, how to do that by writing that as a mixed number, that 5 halves is really 2.5. And that's why you get u squared u to the 1/2 power. So that makes things a little bit easier. Let's change to blue. 12 pi over 5, u squared square root of u. We're going to need f of 5 minus f of 0, which will be 12 pi over 5, 5 squared square root of 5 minus 12 pi over 5, 0 squared, square root of 0. Okay. Square root of 0 here. So this portion is 0. And it looks like we can cancel one of these 5s. So we end up with 60 pi square root of 5. So here's going to be your surface area. So there you go, ladies and gentlemen. Here is the answer to question number 8.